All right, folks, it's Bass Action, back in action here. On this video, again, we're going to go over some things that are some pretty basic algebra, but it's some stuff that I want to touch on in a way that you may not have thought about in the past. Now, if you're already really comfortable with remembering the distance formula and the midpoint formula, this example number 2 probably isn't going to be a big concern, but I am going to go through the proof of that so that you can understand where they come from, which will always make it easier to remember them. On example 3, you'll see I've already filled that out, and you might want to pause the video, quick copy all that down, because I'm going to go through a distance, midpoint, and slope questions specifically with fractions. I want to take a moment to talk about how to work with our fractions if we do not have a calculator, because we will not be using calculators for the majority of our school year, and you will not have them on the midterm or the final, so you've got to be comfortable working with just some simple fractions. On the bottom, I'm going to cover some basic symmetry stuff, and that part will go really fast. All right, let's jump in very quickly to these proofs, just in case you haven't seen these before. So let's say on example 2a here, I'm asked, I'm working with the distance formula. You might be asked, let's say, to find HE, meaning the distance, or they might even write it with a D and then in parentheses give the segment name. You might see it a variety of ways, but both of them are asking you to find the distance. So let's say I have this point x sub 1, y sub 1, and point E is x sub 2 and then y sub 2. And if I was asked to find the distance between these, what I would actually do is I would visualize a nice right triangle here. Okay, if I visualize that right triangle and then I start thinking about the fact that I want to find this distance, I'm going to imagine this leg of the triangle being the difference between these two x coordinates. Now, it doesn't matter what order we do the subtraction as long as we're consistent for the x and the y's. So I'm going to write x sub 2 minus x sub 1. I can write a similar expression for the vertical leg being the difference between these two y values. And again, I'll do y sub 2 minus y sub 1. So if I'm looking for the distance for this, what I'm really just thinking about is the Pythagorean theorem on this triangle. So I'm simply thinking that the hypotenuse squared is going to equal one of the legs squared, x minus 2 minus x sub 1 squared, plus the other leg squared, y sub 2 minus y sub 1 squared. So then, of course, the distance would simply be the square root of that entire expression. So x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So that would be our distance formula. So the big idea here is really just to remember and connect that the distance formula is simply the Pythagorean theorem. Now, on our midpoint formula, you of course have done midpoint plenty of times. You did it lots in geometry. Remember, that would be our midpoint. Geometrically, we would mark those two segments to be congruent. So we, again, would have an x sub 1, y sub 1, and then a comma there, and an x sub 2, and a y sub 2. And what you should remember from your geometry days is that the midpoint is simply the average. And the more you can get this idea of average in your head, the easier it's going to be for you to remember that to find our midpoint, we average the x's, and if you're going to average those, you're going to add them. We add when we're doing an average, so we need to get the average of the x's and the average of the y's, meaning we're going to just simply add those, and it does need to be written as a nice ordered pair, okay? Now, let's take a look at this distance, midpoint, and slope question in terms of working with some fractions, okay? Because this is actually the part where students kind of struggle because they've gotten really comfortable using their calculators all the time. So what I've done here is I've set this up. So if I'm asked to find the distance, I'm going to go ahead and I'm going to do my subtraction. Remember, it didn't matter whether I did the b minus a or the a minus b. I just needed to be consistent. So I've set this up as 3 minus my 2/5, and then the 1 minus my negative 2, and I jumped straight to the plus. Now, the catch here is that I'm going to need to get some common denominators. You might be able to do this in your head, in which case, great. Otherwise, we're going to put this over 1, and then we're going to mentally or even physically write it out, that 5 over 5. That's going to allow us to be able to see that we have a 15 minus a 2 that'll give us a nice 13 squared, and that's where this 169 came from. The common denominator is 5, and I have to square that as well. That's where that 25 came from. And then, of course, my 1 plus 2 is my 3. I squared it and got the 9. Now, in the next step, I'm going to need to get common denominators again. So I'm going to put that over 1. I'm going to multiply this top and bottom by 25. Now, sometimes these numbers do get a little bit big. This 9 times 25 isn't as bad because we could think in terms of money, but typically if the numbers get kind of cumbersome, I'll let you use a 4-function calculator. So if we go ahead and then we add these, if we add all this together, we get a numerator of 394. A denominator, our common denominator was 25. So our final answer then we could write is the square root of 394. That does not simplify. If it did, we would need to all over 5. Okay. Now, on the next one, our midpoint, we're going to, again, work with some of our fractions here. So on the x-coordinate, we're going to need to add those two x-coordinates together. So what we can see again is we're going to either mentally or physically picture adding those together, getting that common denominator. So again, a 15 plus 2 is 17, so that's where this 17 over 5 came from. And then where I had divided by 2, I don't really like to have a fraction over another number. Fractions inside fractions just get complicated. So once I got this 17 fifths, I went ahead and multiplied by that reciprocal, so times a half. The second part, the y's, were much easier. So I had my y minus my 2. That simplified very quickly. Now I can just multiply these two fractions, multiplying straight across, and get my final answer there. If this fraction work is kind of feeling overwhelming to you because you kind of maybe got too reliant on your calculator through the years, please feel free to see me and I can help you out with this and just get you basically some simple basic practice. On our slope, we've got rise over run. So I'm going to subtract my y values. So I did 1 minus the negative 2, and then my 3 minus my 2 fifths. Once again, I found my common denominators. So this time I had 15 minus 2. That gave me my 13 fifths. And then I went ahead and I flipped my division to my multiplication. So I did 3 times that reciprocal, multiplied straight across, and there's my slope. Okay, I went through that pretty quickly. Depending on your comfort with fractions, you may need to pause and rewind it. The last thing we're going to look at is some symmetry here, and this part's going to be really simple, and then we will eventually ramp this up. We're going to take a look at some graphs that are symmetrical, and what I want you to notice is that if we have something that's symmetric with respect to the x-axis, when we move a point to the other side, when we flip it over that x-axis, what I want you to notice is that only the sign of the y-coordinate changes. So everything else stays the same, just that sign changes. If I want to have something symmetric with respect to the y-axis, what I'm going to have here is I have this point and it's going to come over here. So what I can see is that when I move this point over here, when it's symmetric with respect to the y, it's the x-coordinate that changes. And then lastly, when we have it symmetric with respect to origin, so for example, this point comes over here to this point, then what we're going to notice is that the signs on both x and y change. So let's take a look here. If I give you this point, let's say this point 3, 2. And I want you to find the point that is symmetric with respect to the x-axis. That means that I'm wanting you to flip it down here, and you may or may not for a while need to actually physically plot it, and what you can see is that the y-coordinate would change. So I'd still have a 3, but the y-coordinate would flip its sign. If I wanted to take that and I wanted to flip it over the y-axis, now to make it symmetrical, right there, all that's going to change is the sign of the x-coordinate. So it's the opposite. And then lastly, if I want to make it symmetric with respect to origin, I'm going to move it over here. So now both signs are going to change. Most of us tend to be pretty visual, and we probably need to actually draw those pictures. Some of you are going to be better with that mental gymnastics than others. On the next page, there is a reflection question, and I'd like you to just take a moment to flip that page in your notes, read that reflection question, and go ahead and jot those answers down so that we can discuss them in class.